One step in measuring spoke length is determining what's called the effective rim diameter. Let me show you how to do that for a couple different situations. We'll look at a wheel with regular nipples and then a wheel with internal nipples. Let's start with a wheel that has regular nipples. ERD is not the internal rim diameter or the external rim diameter or the bead seat diameter. There is a regular nipple. That little diagram is a cross section of the rim, and that is the part that we call the spoke bed. Here we see the nipple extending through the cross section of the rim. That represents the thickness of the spoke bed. Here we see the spoke bed thickness highlighted on both sides of the rim, and that part of the nipple there has to extend through the spoke bed thickness. Here's an expanded cross section of the rim on each side, and there is the slot on each nipple. The effective rim diameter is the distance from the slot on one nipple all the way through the rim, all the way across to the other side to the slot at the end of the other nipple. These are the actual steps in determining the ERD. First, we have to measure the internal rim diameter, then we measure the nipple length, then the nipple drop, and then we actually calculate the ERD. The system I like to use to determine the internal rim diameter I got from John Barnett of the Barnett Bicycle Institute in Colorado Springs. What you do is you take 2 metric yardsticks, if I can use that term. Each of these is 1 meter long. Then we're going to make 3 vertical cuts with a sharp hacksaw. One is going to be right here, slightly to the right of the 350 millimeter mark. Then in the other yardstick, one cut slightly to the left of the 350 millimeter mark and one slightly to the right of the 700 millimeter mark. Now, you actually have to use 2 meter sticks because some metal is lost in the cutting. With the first meter stick, I discard that piece, and that leaves me with a section that's exactly 0 to 350 millimeters. And with the other meter stick, I discard the 2 end pieces, and that leaves me with a piece in the middle that's exactly 350 to 700. These 2 pieces here are then my tool to measure the internal diameter. My 350 to 700 millimeter piece is shown there, and my 0 to 350 piece is shown there. We'll look at a close-up of this in just a second. We're measuring here from a hole on one side of the rim all the way across to a hole on the opposite side. This is a 36-hole rim, so besides those 2 holes where the ruler is, I have 17 holes on one side and 17 holes on another. It's not a bad idea to actually count the holes on either side of the ruler just to make sure that you're actually measuring the diameter. If we look at a close-up section of where these rulers overlap, that's 480 millimeters, that's 490, and right there where the 2 rulers overlap is 500 millimeters. And that 500 millimeters is the internal diameter of my rim. It's not the ERD, but it's the first step in determining the ERD. Now, if you have a rim that has eyelets, for example, as shown there, make sure you position your ruler next to the eyelet, not on top of it. Step 2 in determining ERD is to determine the nipple length, and for that I need a caliper. A caliper allows me to measure 3 dimensions. One is the outside dimension of an object, also the inside dimension, and the depth. This is my prized tool, my Mitutoyo caliper, and boy do I love this tool. I use it every day. It's very high quality, it's digital, it's accurate to 2 decimal places, and it can be used to measure either inches or millimeters. Normally you're using millimeters, but it does convert to inches as well. Here I'm measuring a nipple length. It's important to note that the caliper is inside the nipple slot. So I'm measuring a distance of 10.74 millimeters, which is the inside of the slot to the end of the nipple. Step 3 in determining ERD is to determine what's called the nipple drop. That's that distance there, which is the distance that the nipple drops or sticks through the rim. Here I can use the depth gauge of my caliper to read the nipple drop, which in this case is 6.8 millimeters. So let's calculate the ERD. There's my nipple, and there's the nipple length from the bottom of the slot to the other end of the nipple. That's the spoke bed that the nipple has to go through. That's the nipple drop that sticks out into the rim, and that right there represents the difference between the nipple length and the nipple drop. My ERD is the internal rim diameter plus 2 times the nipple length minus the nipple drop, which is 2 times the difference. Let's look at another diagram to illustrate this. We have a rim and 2 nipples shown expanded there at the bottom. That would be the internal rim diameter. That would be the nipple drop, the part that sticks out into the inside of the rim. And shown there is the difference between the nipple length and the nipple drop for each nipple. My ERD will be the internal rim diameter plus both of those differences added together. Let's look at a specific example for a velocity diad rim, a 700C rim, and we have a 590 millimeter internal diameter. I'm using a nipple that has a length of 10.70 millimeters, and I can measure my nipple drop of 7 millimeters. So my ERD is equal to 590 plus 2 times 10.7 minus 7.0, and that equals 597.4 millimeters, which is the ERD of that rim. That section was all about rims with normal nipples, where when you look at the holes are relatively large, and there's enough room for the nipple to visibly come through the rim. But there are many wheels where the nipples are internal and are hidden, and we have to know how to calculate ERD in that case as well. With internal nipples, there's a little tiny hole in the rim, just enough room for the spoke itself, but the nipple is inside. We measure the internal rim diameter the same way as we did before, but the nipples are measured differently. Making use of the same diagram as we've used before, we have a rim and a rim cross section that you can see with the spoke bed shown. In this case, however, the nipples are going to be entirely on the outside of the spoke bed. None of the nipple will come through the spoke bed. My ERD in this case is from the end of one nipple all the way through the rim to the end of the other nipple. Let's take this wheel that has internal nipples and look at it in cross-section and see what actually is going on the inside of the rim. Here's our rim, piece of it, and here is a cross-section of the piece of the rim. That is obviously the outside of the rim, and that's the inside of the rim, and that part right there is the thickness of the spoke bed of the rim. There are many different kinds of internal nipples. This is one common type that's used, though, about a 10 millimeter long aluminum hex nipple. And if you look closely, you'll see there's a slight bevel here on one end of the nipple, and that's the part of the nipple that actually goes against the rim. That part points away from the rim. Here's our cross section of the rim, and here we see a spoke coming through the small hole through the rim. We see the threaded portion of the spoke sticking into the inside of the rim, and here we see our internal nipple screwed on all the way. Notice that the threads on the spoke go all the way to the end of the threaded part of the nipple, and that the nipple is flush with the inside of the rim. The question is this: how can I measure this thickness of the spoke bed without having to saw the rim in half? Make yourself this little spoke bed thickness measuring tool. You just take a spoke and screw a hex nipple onto the end of it, and by screwing that nipple in or out, I can vary the amount of spoke that sticks out the end of the nipple. Here's my little tool, and I'm going to use it to measure the depth of the spoke bed in that internal nipple rim there. And when this end of the spoke, when I push that tool all the way through the rim, when that is flush with the outside of the rim, then this distance here will be the spoke bed thickness. And I've done that here with this little piece of Reynolds rim. You can see the end of the spoke right there, and it's flush with the inside surface of the rim. So I just use my caliper and I measure the spoke bed thickness of, in this case, 3.4 millimeters. Here's a section of rim that has a spoke bed thickness of 4.25 millimeters. Here is a section of a Reynolds tubular rim, and I've determined 3.2 millimeters. So here's a situation where I can calculate my ERD, which is going to be the length of the internal nipple, plus the thickness of the spoke bed, plus the internal diameter of the rim, and then the thickness of the spoke bed on the other side, and then the length of the nipple on the other side. So there's my ERD, the internal rim diameter plus twice the spoke bed thickness plus twice the nipple length. In addition to that aluminum hex nipple, there are other kinds of internal nipples. Some of the ones I like are from a company in Belgium called Sapim. This is a picture of one of those nipples. It's an inverted nickel-plated brass nipple, which I like very well. We'll talk about that and some other ones in the chapter on nipples. If I were to use some of those little Sapim nipples, I'd see a diagram like this, and that would represent the threaded portion of the nipple. So my ERD is equal to the internal rim diameter plus twice the spoke bed thickness plus twice the length of the nipples.